Hello, welcome to the Queensland Paper 2 Tech-Active Section 2 Solutions. Okay, so let's have a look at the questions here. Question 11, the first 10 were multiple choices. Basically, this is one of those matrix sort of questions worth 5 marks. Now, we've got 5 teams participating in a competition. A defeated D, B defeated A, C, and E, C defeated A and E, D defeated B, C, and E defeated A. We want to rank these teams using a dominant matrix N. Okay, so we're going to use a 1 to represent defeated, and a 0 was either defeated by or no result, for example, when they played themselves. Okay, so we're given a matrix to put in the results. So what are we going to do? Well, A defeated D. So there'll be a 1, there'll be in the top row, there'll be 0, 0, 0, 1, 0. B defeated A, C, and E. So there'll be in the second row, there'll be a 1, 0, 1, 0, 1, etc. And C defeated A and E. So there's a 1 in the third row in the first column and a 1 in the first row, fifth column. D defeated B, C, and E defeated A only. So there's a 1 in the first row of the last column, last row there as well. All right, so what we want to do is we want to now use a ranking model. The ranking model that the organisers want to use now is n plus n squared to rank these teams. So we're going to go to our TI-Nspire non-cas calculator, and we will enter this data in a matrix. All right, we will insert a matrix on the calculator page. Number 7, matrix, create. We'll create a matrix which has got 5 rows and 5 columns. Now, because A defeated only D, we'll have zeros here, a 1 here, and zeros here. Notice that I'm tabbing between each field. B defeated A, so there's a 1 there, 0, 1, 0, and 1. Tab. Press tab all the time here. C defeated A and lost to all the others. Tab again. D lost to A. D defeated B and C and E. Tabbing again. E defeated A only. So the rest of these are zeros. Let's press the right arrow button and store this matrix as N. All right, so the ranking model that the organisers want to use is N plus N squared. Now, how does that actually achieve anything? Well, what we really want to do here is we want to sum the rows. So you can see that the sum of the first row is 4, the sum of the second row is 7. So let's try summing. Well, let's store that matrix A to A. N plus N squared is stored as A. Assigned equal is exactly the same as storing. Sum of A. Okay, well that actually summed all the columns, didn't it? We don't want to do that. We want to sum the rows. So we can swap the rows and columns around by making the transpose of the matrix. So let's type in A, but now go to the menu and go to Matrices and Vectors, and option number 2 here is the transpose. So what this means is that A has got a ranking points of 4, B has got a ranking points of 7, C has got a ranking points of 4, D has got 9, and E has got 2. Okay, so let's go back to our question. Use the model to rank the teams. Well, there's our information there. So based on this ranking, you can see that D has got the highest ranking, 9. B has got the second, which is 7, but A and C are equal on 4, and E is finally the worst one on 2 there. So that's the answer there. So there are two possibilities there, DBCAE or DBACE in the ranking order from 1st to 5th place. Well, what's the limitation of the organizer's ranking model? Well, the obvious limitation here is that A and C are equal. That you can't distinguish between A and C. It gives equal rankings to both A and C, yet C beat 2 players, including A, while A only beat 1 player, which was D, but D was the highest ranked player. These sort of things happen, in little tournaments as well. So that's a bit of a limitation in the organizer's ranking model. State a mathematical refinement that could overcome the limitations of this ranking model. Well, a number of possibilities that we could here. Probably just try n squared. And if I just try n squared, this gives me the ranking model of D, B, A, C, and E. Okay. Another possibility might be n plus a half of n squared, or something like that. So there's lots of possibilities to answer this question here. All right, question 12. Now, in a certain experiment, the number of yeast models, n, after a time t hours in the test tube can be modelled by that differential equation, dn dt equals 1 over 1,000 n 1,000 minus n. That's only defined for t greater than or equal to 0. Given that 1,000 over n times 1,000 minus n equals 1 over n plus 1 over 1,000 minus n, show that the differential equation can be expressed as that. All right, so there's not a lot that we can use our calculator on here. It is a show that question, so we have to physically show it. So let's start with the original differential equation, which was given to us in the question, and tip that one upside down. So when I tip it upside down, or invert both sides, I've got 1,000 over n times 1,000 minus n. And the partial fractions decomposition of that is given to us as 1 over n plus 1 over 1,000 minus n. Okay, so we can integrate both sides with respect to n there, take the dn across to the other side, put a constant of integration on the left-hand side, or t is the indefinite integral of that. The integral of 1 over n is log mod n minus log 1,000 minus n in a modulus as well, and log minus a log is the log of the division there. So that is the solution, or the general solution, of that differential equation. Remember, a general solution is one which has an arbitrary constant in it plus c. Okay, so that was part A of the question. Part B of the question, well, if we start this experiment at 9 a.m. on a certain day, and 100 cells were observed after time of this time. So what does that mean? Well, that means initially, when t equals 0, which will be 9 a.m., n is equal to 100. We have to show that the solution of this differential equation can be expressed as n equals 1,000 over 1 plus 9 e to the minus t. Okay, so we've got the initial condition. The last slide on the bottom page there, on the last page, if I put t equal to 0 when n equals 100, that will enable me to find the constant of integration there. So c is equal to log e of 100 over 900, which is 1 over 9. So let's put that c back where we got it from. It was t plus c. So let's put the c across to the other side. So t equals log e, or natural log, n over 1,000 minus n, minus log e 1 over 9. Now, using a log law, minus log e 1 over 9 is plus log e 9. The 9 then gets multiplied up to the top. So t equals log e 9n over 1,000 minus n. Now, I've dropped the modulus out of there because the value of n, well, I sort of know the value of n is only going to be between 100 and 1,000. It can never be anything else. So in this case, the moduluses are now not needed. All right, so what we have to do now is we have to rearrange this formula to get n the subject. So if we get rid of the logs here, then we'll have e to the t equals 9n over 1000 minus n. Once again, tipping that upside down, 1000 minus n over 9n equals e to the minus t. Take the 9n across to the other side. So 1000 minus n equals 9n e to the minus t. Take the n across to the other side. So 1000 equals 9 n e to the minus t plus n. Take out the common factor of n. Divide by the 1 plus 9 e to the minus t. And we have the solution given as that was what's required. So a bit of work there. Determine the time of day when 900 yeast cells were present. Okay, well, we want to find the value of t. We had an expression before. We don't really have to go to the final answer of n equals. Let's go back to the line where we had t equals. We had t equals log e 9n over 1000 minus n. So if I want to find t when n equals 900, let's just substitute n equals 900 into that. That'll give me 9 times 900 over 1000 minus 900, which is log e 81. And we can easily work that out to see that it's 4.39. Or after 9 p.m., that'll give us at 1:24. I'll show you how to do that in a second. But let's just continue with the next part, and then we'll come back to the calculator in a moment. The next part of the question was the scientists predicted that the number of yeast cells would eventually exceed 1200. Evaluate the reasonableness of this scientist's predictions. Well, I don't think this scientist knows much about maths, do you? Because we've got a function n equals 1000 over 1 plus 9 e to the minus t. If I think about the limit as t approaches infinity, the 9e to the minus t goes to 0, and the limit there is 1000. So the number of yeast cells approached 1000. The scientist, I think, is clearly wrong here and needs to study some more mathematics. All right, so let's define our function that we've got here. So we'll go Menu, Actions, Define. I'll define f1 of x to equal, and we'll use the template here, 1000 over 1 plus 9 e to the minus x here. So we're using x's instead of t's, but that's okay. All right, I want to solve when this is equal to 900. So on this calculator, we have to go Menu, Algebra, Numeric Solve. So that's N-solve. N-solve f1 of x equals 900, and I want to solve that for x. So that gives me 4.39 as the time. Well, we know that that's after 9 a.m., isn't it? So let's take my last answer and subtract off 4, gives me 0.39. And if I multiply my last answer times 60, that gives me 23.69, which is rounding up to 24. So that gives me the time as 1 o'clock and 1:24. Okay. So that explains how we got the 1:24 there. All right, question 13. Data records show that the speeds of a car traveling along a highway are normally distributed. Now, sometimes these values here are sort of important, so let's figure out what all these values are. Okay, and we've got 20 cars there. Determine the probability the expected value will be traveling within plus or minus 1. All right, so what do we know here? We know that the speed of the cars are normally distributed with a mean of 98.7 and a standard deviation of 4.1. All units are in kilometers per hour here. Okay, so the speeds of one car normally distributed. If they're within plus or minus 1 kilometers of the mean, that means we want to find the probability that the speeds are between 97.7 and 99.7. Now, show you how to do that one on the CAS. So that gives me 0.193. And if we're talking about the expected number of 20 cars, then let's just multiply that by 20 to give me 3.8 cars. So we have to round our answer up to 4. Okay, so let's do that on the CAS. How do we do that? Well, let's press Menu, Probability, and this time we want to go down to Distributions. We're using normal CDF here. What was my lower bound? My lower bound was 97.7. My upper bound was 99.7. My mean was 98.7. And my standard deviation was 4.1. Tab to OK. That gives me my answer of 0.193. And once again, we just wanted to multiply that times 20 to get the expected number of cars. 3.8, but we have to round that up to 4. Okay, part B of the question. This time we want to find the probability that the mean sample will exceed the speed limit. So what's the mean of the sample? When we have the mean of the sample, we have to include the 20 randomly selected cars. So this time we've got the sample mean. What's the sample mean? The sample mean is still normally distributed with a mean of 98.7, but the standard deviation is 4.1 over root 20. Or the variance is 4.1 squared over 20 because I've got a sample size of n equals 20. So the probability of S bar being greater than 100, the answer there is 0.078 or 0.08 to 2 decimal places. Okay, so let's get that answer on the calculator. Well, I could go through normal CDF again, or we could just type up arrow and edit that, switch that one there. So let's try that. Let's go up arrow and let's edit it this time. So what did we want here? We wanted greater than 100. So let's edit that one to 100. And we need to type in a very large number here. So let's type in 1 to the power of, or 10 to the power of 99, or E99. Okay, the mean was the same, but the standard deviation now is 4.1 divided by root 20. So that's my answer for part B of the question, 0.08. Okay, part C of the question, there's a 5% chance that the probability that the mean speed will exceed some value k. Determine the value of k. Well, what are we saying here? We're saying that the probability of S bar greater than k is 0.05. Remember, if we want to do inverse normal questions, we always have to have less thans. So that would mean that the probability of S bar less than k is 0.95. Okay, so what do we have to do now? We want to find an inverse normal of 0.95. Okay, so let's do all this on the calculator now. Let's go inverse normal, menu, probability, distributions, inverse normal. What's my area? My area is 0.95, 0 and 1 are okay. So that gives me the value of 1.645. Well, what do I want to do now? That's my Z value. So my Z value is X minus mu over sigma. So my X value is X minus mu, X is K. So what I want to do now is I want to go menu, algebra, Nsolve, and what am I solving? I'm solving K minus mu, which is 98.7, over sigma, and sigma is 4.1 over root 20, because that's my standard deviation. And that's equal to 1.6485. Doesn't matter so many decimal places. And I want to solve that equation for K. So that gives me the answer there as 100.21. So we solved that equation, gave me my answer there as 100.21 kilometers per hour. All right, so there's all the screen dumps that we needed to solve there. All right, question 14 is another probability density function. The time, t months, that it takes before a phone owner cracks the screen on their mobile is modeled by an exponential distribution. F of t equals 0.16 e to the minus 0.16 t. That's for t greater than or equal to 0, or 0 otherwise. All right, we have to show that f of t is a probability density function. Well, to show it's a probability density function, we have to show that the total area under the curve is 1. Okay, so to show that the total area under the curve is 1, we have to integrate between 0 and infinity of f of t dt, which is 0.16 e to the minus 0.16 dt. Now, we can't really do it with an infinity there, so we're really going to say that that's the limiting value as n approaches infinity of 0 to n. Okay, the integral of e to the kx is 1 over k e to the kx, so the 0.16 is going to divide itself out, just leaving me with a negative sign there. So that's the limit as n approaches infinity of minus e to the minus 0.16 t between n and 0. So when I substitute in n equal to 0, I've got the limit as n approaches infinity of e to the minus n, and that goes to 0. I subtract off plus, so it becomes plus e to the minus 0, which is equal to 1. So we've shown that result. As I said, to show that, you can't just put in a screen dump from a calculator. You have to show it. All right, part B of the question. Let's find this one. Find the probability that the phone owner cracks their screen within 1 year. Now, hold on a minute. What time? We're measuring in months here. Months. Okay. So 1 year. What does 1 year mean? 1 year is 12 months. So we want to find the probability that between 0 and 12. Well, that's the definite integral between 0 and 12 of 0.16 e to the minus 0.16 dt. We can do sort of this one by hand. When I do the integral, it's just minus e to the minus 0.16 to be evaluated between 12 and 0. So substitute in 12 minus e to the minus 0.16 times 12 plus e to the 0, and that gives me 0.853. So let's just try that one on our calculator. I'll define the function. Since I'm going to be using it probably again, we'll go menu, actions, define. I'll just call it f of t. I'm not going to graph it. So it's 0.16 times e to the minus 0.16 times t. Okay, so we want to find the probability that it's going to be within a year, so we want the definite integral between 0 and 12 here. We can get that from a number of places. I prefer to get it just from the template next to the book. And yep, that's it. So type in 0, up arrow to 12, and because I've already defined f of t, let's just type it in, get it from the variables command, and that's the answer there, 0.853. All right, now the last part of this question, 3/4 of phone owners take between 1 and m months before they crack the screen. on their phone. Find the value of m. Okay, so what this is basically saying is that the probability between 1 and m is equal to 3/4. So that's the equation that we're after there, and we want to solve that equation for m. Well, let's try doing this one by hand. It's the same definite integral. Substituting in m for t gives me minus e to the minus 0.16 m plus e to the minus 0.16, because that's when t is equal to 1, and that's equal to 0.75. We're trying to solve for e to the minus 0.16 m, so that equals e to the 0.16 minus 0.75. 0.16 m equals log e of that, so m then will equal minus 1 over 0.16 log e of e to the minus 0.16 minus 0.75. And that comes to 14.26. All right, so we could get that on our calculator. Let's see how we get that on our calculator. All right, so let's try to solve. Let's start. Let's solve that equation that we had. So we'll try to do this on the calculator. Menu, algebra, numeric solve. What am I solving? I'm solving the definite integral between 0 and it's between 1 and m of f of t dt equal to 3/4, and I'm solving that equation for m. Sure enough, that gives me the answer of 14.26 months. All the screen dumps are there. Okay, question 15 is some vector questions. So we've got two position vectors, points P, 2i minus 3j plus 2k, and Q, 2i plus 2j minus 4k, and O is the origin. And we want to find the angle POQ. Okay, so let's write out our vectors, OP and OQ. We want to find the magnitude of these vectors. The magnitude of the vector OP is going to be the square root of 2 squared plus minus 3 squared plus 1, which is root 14. Similarly for OQ, which is 2 squared plus 2 squared plus minus 4 squared, which is 4 plus 4 plus 16. And we want to find the dot product. We do the i's with the i's, the j's with the j's, and the k's with the k's. So that's 2 times 2 plus minus 3 times 2 plus 1 times minus 4, which is 4 minus 6 minus 4, which comes to minus 6. And then we want to find the dot product, or using the dot product, we're using the formula here. Cos of the angle is equal to the dot product over the magnitude of both the vectors. So cos of theta is equal to OP dotted with OQ over the magnitude of OP times the magnitude of OQ. In other words, theta will be then the r cos of minus 6 over root 14 times root 24. And we could give our answer in either radians or degrees here. We'll give our answer in radians here, which is 1.9 radians. All right, let's see how to do this one really nicely on the calculator. We can store a matrix as a vector, sort of like a vector, but it's a 1 by 3 vector. So let's go menu, matrix, and let's create a matrix. How many rows? 1. How many columns? 3. And let's enter the points from the vector or the matrix P. It was 2, tab, minus 3, tab, 1. Let's get out of that by going right arrow, and let's store, control, store. Let's store that to P. Now I could create another one, but probably easier just to press up arrow and edit that one, change that one to Q, and press the back arrows and change the values of Q, which were 2i plus 2j minus 4k. All right, now, how do we find the magnitude of a vector here? Well, let's go Menu, Matrices and Vectors. Norm is what we want here. So we want to find the magnitude of a vector, which is the norm of the matrix or the vector P. Sure enough, that is the correct value. That is the equivalent value of root 14. Let's just check that. Square root of 14. Yep. Also, we want to find the norm of the vector Q. So let's just press up arrow, change that to a Q, and that should be the value of root 24, which it is. How do we get the dot product? Let's go Menu, Matrices and Vectors. This time, let's come down to Vectors and dot product. So dot product of what? P, comma, Q. Sure enough, that's minus 6. Okay, so with my calculator in radians, what do I want? I want to find the RCOS. So let's press the trig button. The RCOS of the dot product over norm. Now I can just type these in. Norm P times norm Q. And that gives me my answer in radians there of 1.90. Now, I might need that in subsequent calculations, so let's try and store that. I'll find theta. Where's theta? If I go to the control book command, there's some Greek letters there, alpha, beta, gamma. So let's go theta, and theta is assigned equal to that value. So let's store the value of theta. So that was part A of the question. Part B, find the area of the triangle. Well, there is a formula for the area of a triangle, and it's a half the magnitudes of the two side lengths times the sine of the angle. So that's why I said it would be nice to store that value. Let's just check that value on the calculator here. It's 1 over 2 times, it was the norm of P times the norm of Q times the sine of that angle. So I press the trig button and get that value back again. So that gives me 8.66 as the formula for the area of the triangle. Now there is another formula that I can actually use to find the area of a triangle, and that's a half of the cross product of the two vectors. So let's try that one. 1 over 2 times the cross product. Where will I get the cross product? Well, let's go Menu, Matrices and Vectors, come down to the very bottom till we find vectors. The first option there is unit vector. Dot product was option number 3. What we really want here is the cross product of P, comma, Q. That's going to give me the vector. But what I really want then is the norm of that vector. Sure enough, that's also 8.66. So there are two ways of doing that question. One using the formula a half BC sine theta, and the other one using a half of the cross product of the vector. Okay, all the screen slides are shown there. All right, question 16. Can't use our calculator for this one. We have to find the values of A, B, and C using Dumoir's theorem here. So we want to prove that cos of 4 theta is equal to A times cos to the 4 theta plus B sine squared theta plus C. And A, B, and C are positive or integers there. Not necessarily positive, but integers. Well, cis theta is cos theta plus I sine theta to the power of 4. Cos 4 theta plus I sine 4 theta. So the left-hand side that we want there is just cos of 4 theta. And we'll use the binomial theorem to expand out cos theta plus I sine theta all to the power of 4. Now when I do that, we get cos to the 4th plus 4 cos cubed sine theta times I, 6 cos squared theta sine squared theta I squared, plus 4 cos theta sine cubed theta I cubed plus sine to the 4th theta I to the 4th. That's just the expansion of a plus b to the power of 4, which is a to the 4th plus b a to the 4th plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus b to the 4th. Now we only want the real parts here. So we can get rid of the second term because it's got an I in it. The third term there has got an I squared, which is minus 1. The last term has got an I to the 4th, which is 1. So we're only using the first term, the middle term, and the last term there because I only want the real parts. So equating both the real parts will give me cos to the 4th minus 6 cos squared theta sine squared theta plus sine to the 4th theta. Now that's nearly sort of what we want our answer to be in, but we don't want sines to the 4ths. So what else do we know here? We know that sine squared plus cos squared is equal to 1. So let's replace the sine squared with 1 minus cos squared, and the sine to the 4th as 1 minus cos squared all squared. And do a little bit of algebra there and expand it all out. That'll give me some cos to the 4ths, a bit of algebra here. And finally, we don't want a cos squared, we want a sine squared. So let's replace the cos squared with 1 minus sine squared, and we'll get our final answer there as 8 cos to the 4th theta plus 8 sine squared theta minus 7. So that'll tell me that A is equal to 8, B is equal to 8, and C is equal to minus 7. Can't use the calculator for this one. State an appropriate method of verifying your answers from 16A. Well, a couple of possibilities here. Could use a double angle formulae, which is another method that we're asking to do here, because we use the binomial expansion to expand the cos theta plus I sine theta to the power of 4. And that line agrees with the lines above. Another alternative method would be perhaps compare the graphs and to see that the two graphs of the left-hand side and right-hand side are the same as well. Okay, so that's question 16. Once again, calculator not very useful. Well, we can't use the calculator for that one. All right, question 17. An object is released from rest at a height of 100 meters above the ground, and while it's descending, it's modeled by the differential equation v dv dx equals 9.8 minus 0.004 v squared, where v is greater than or equal to 0. V is the velocity in meters per second, x is the displacement in meters from the ground. Now that's important there. Determine the velocity of the object when it strikes the ground. Okay. Well, let's start with that differential equation, v dv dx, and let's just divide both sides by v. So we'll get dv dx equals 9.8 minus 0.004 v squared over v. And now we'll invert both sides. So that will give me what dx dv equals v over 9.8 minus 0.004 v squared. Okay, so if we integrate both sides with respect to v now, x will equal the indefinite integral of v over 9.8 minus 0.004 v squared dv. Now, we're going to have to perform that integral. So let's have a look at what the derivative of the bottom line would be. The derivative of the bottom line is going to be what? Minus 0.008v, right? Because v squared is 2v. We only have the v on the top there. Okay, so if I perform that integral, x will equal what? Minus 1 over 0.008 log e of that modulus plus c. Okay, now I'll put the c on the right-hand side there. It doesn't matter, we only need one c on either side of the equation. Now this gets a little bit tricky because downwards is positive, isn't it? So the origin is 0. So where was the particle initially dropped from? Initially the particle was dropped from a point 100 meters above where it was initially from. So in other words, to find the value of c, we need to use that x is equal to minus 100 when v was equal to 0, because it was 100 meters above where it started from. So let's substitute x equals minus 100, substitute v equals 0, 1 over 0.008 is minus 125, and that will give me c equals minus 100 plus 125 log e 9.8. So let's substitute that c back where we got it from. So x equals minus 125 log e mod 9.8 minus 0.004 v squared minus 100 plus log e 9.8, or yes, or g. So the 9.8 is g. Okay, so let's use the log law again. X will equal 125 log e 9.8 divided by 9.8 minus 0.004 v squared minus 100. We sort of need the modulus at this stage. Well, what's the question asking? It's asking for the velocity when it hits the ground. Well, when it hits the ground, x is equal to 0. So we want to solve that equation now for v when x is equal to 0 when it hits the ground. So we've got this equation. Let's take the 100 across to the other side. So 100 will equal 125 log e 9.8 over 9.8 minus 0.004 v squared. We want to divide both sides by 125, which is 100 over 125, which is 0.8. And now we want to throw away the logs, or get rid of the logs. So this is pretty heavy stuff here. It was a little joke if you got that one, but anyway. So 9.8 over the modulus of 9.8 minus 0.004 v squared equals e to the 0.8. The v that we want is in the bottom, so once again we're going to have to invert both sides. E to the minus 0.8 is the modulus over the 9.8. Take the 9.8 across to the other side, and we realize that that must be positive on the right hand side. So let's just write the modulus and delete the modulus signs as 9.8 minus 0.004 v squared. We want to solve this equation for v. So 0.004 v squared is equal to what? 9.8 minus 9.8 e to the minus 0.8. Take out the 9.8 as a common factor. Divide both sides by the 0.004, and now v would really be plus or minus, but because v is actually a positive number, v is the positive square root of 9.8 outside of 1 minus e to the minus 0.08 over 0.004, which is 36.7. And that happens because we know that v must be positive. All right, let's see if we can actually do that on our calculator. Just the last line first of all. So let's go just to show you how we got that final answer. Using the templates, what was it? It was 9.8 over 0.004 times 1 minus e to the minus 0.8. Sure enough, that's 36.73. Now, there is another way I can actually get this answer. How else could I get this answer? Well, if we think that we're integrating the value of v from 0, because the initial velocity was 0, and I want to find the final velocity when it hits the ground. And that was a distance of 100. So let's see if this is going to work. Let's go menu. This time I'll go to the calculus and I'll do a numerical integral. So I basically want to solve this equation. So let's first of all go nsolve from 0 to my final value, which I'll call VF, which is my final value when it hits the ground, of the definite integral over V over 9.8 minus 0.004 V squared dV, and that must equal 100, and I want to solve that equation for VF. Sure enough, that gives me the answer that we want there, 36.73 meters per second. Okay, so there's the screen dumps for those two. All right, question 18. This is sort of one similar to what we did before when we've got some samples and some standard normal distributions. So what have we got here? We've got a kangaroos with a mean of mu, standard deviation of sigma. When one kangaroo is selected, the probability that the mass being greater than 83.2 was 0.145. And then we have a sample of 12 kangaroos. The mean less than 74.1 was 0.079. Okay, so what's going on here? So these are your harder sort of questions, which are your questions where you've got a lot of information here. So let's try to actually write down what's actually happening here. So first of all, for one kangaroo, the weight is normally distributed with a mean of mu and a variance of sigma squared. Problem is we don't know mu and we don't know sigma squared. But what do we know? We know that if we read the question again, the probability that the mass greater than 83.2 was 0.145. So the probability that K is greater than 83.2 is 0.145. Okay, so if we did an inverse normal on 0.145, we would get 1.0581. Okay, and that must equal Z value, which is X minus mu over sigma. Okay, so equation number 1, 83.2 minus mu equals 1.0581 sigma. Now, what's happening now for the second part? Well, now we've got a sample of 12 kangaroos. When we have 12 kangaroos, we want the sample mean this time. This is similar to one we did before. So when I've got K bar now, the mean of 12 kangaroos, n is equal to 12, this is normally distributed with a mean of mu and a variance of sigma squared on n. The mean of 12 kangaroos had a sample mean less than 74.1, and that was equal to 0.079. Okay, so, all right, so if I do that, if I do an inverse normal for that one, what is that? It'll give me minus 1.4118. And again, that's the Z value, and that's equal to 74.1 minus mu over sigma on root 12, because n is equal to 12. So we have those two equations, equation 1 and equation 2, and we want to solve them for mu and sigma. So let's go to our calculator here. So the first one was a greater than, so I have to turn it around into a probability less than. So that was the inverse normal, and my area was 1 minus 0.145. Yep. Okay, my second value there was inverse normal. What was that area? That was just 0.079. Okay, so now we want to solve those two simultaneous equations. Now, they're sort of linear, so let's try where can we solve some simultaneous equations. Menu, algebra, solve system of linear equations. Yeah, okay, so LinSolve. LinSolve, two equations, yes, but I could use M. I'll use M and S rather than mu and sigma here. So what's my first equation? My first equation was 83.2 minus M equals, what is it, 1.05812 times S. My second equation was 74.1 minus M equals, this time I need a template, so it's minus 1.41183 over what? S over root N. Okay. So it's S over root 12. The S is already multiplied up the top, I think. Okay, so that gives me M equals 76.63 and S is equal to 6.21 as my values there. So we'll need to remember those values. So solving those two equations gives me mu equals 76.63 and sigma equal to 6.21. And we should probably give our answers to 2 decimal places. All right, now that's the whole question there to find mu and sigma, but in fact there's more. What else do we want to do here? Now, that's the first bit. Now, a 90% confidence interval for mu is calculated for a random sample of n kangaroos, and that has a sample mean of 79.1 and a standard deviation which is equal to sigma. Find the possible values of n that could be given if the confidence interval did not contain mu. Okay, so what are we talking about here? What are we talking about? We want to find the values of n this time. Well, for a 90% confidence interval, the z value is 1.645. The x mean, the x bar, was 79.1. S, the standard deviation, is also, and now S is really the sample standard deviation, and sigma is the population standard deviation, but we'll say they're both the same in this case, which is 6.2087, and n is equal to, well, n is unknown. Now, we wanted the lower value of a confidence interval. So the confidence interval is x bar minus z over sigma over root n, and that's equal to 79.1, because that's the lower limit of this confidence interval. So substituting the values, we want to solve that equation for n. Okay, so let's go and try and solve that equation for n. Menu, algebra, numerical solve. What am I solving? I'm solving 79.1 minus it was 1.645, that was the z value, times the standard deviation, which was 6.2087, over root n, call it n1, and that is equal to 76.63, and I want to solve that for n1. The reason I'm using n1 is because n was used earlier in the paper in question 1. All right, so n is equal to 17.0978. So now we want to just check that answer. How can we sort of check what the answer's got to be here? I think the answer's got to be 18, doesn't it? So we want to actually work out if the confidence interval contains the value of 76.63. Okay, so what are we going to do now? We want to find a Z interval. Okay, so what are we doing here? Let's go menu. This time we're going to choose statistics and we're choosing a confidence interval. What confidence interval am I choosing? I'm choosing a Z interval. Have I got data? No, I've got some stats. What's sigma now? Sigma was the standard deviation, which was 6.20872. What was X bar? X bar was 79.1. N, well, we'll try 16, and the confidence level is 0.9. All right, so that's my confidence interval. Does that contain the value? Yes. Okay. Rather than going through all that again, let's just change my 16 to 17. This time I get 76.62 as my lower bound. Does that contain the value? Yes. Let's just try it again and change the 17 to an 18. Does that contain the lower bound? No. Okay. And just double check that. Let's just change that to a 19. No. Okay, so they're all my confidence intervals for the value of n, and do they contain 76.63? Well, yes for the first two, no for the last two. So what's my smallest value of n? Only when n is greater than or equal to 18 will the confidence interval not contain mu as a lower bound. Okay, so that was quite a lot in that sort of question. These are basically, as I was trying to say before, the complex sort of unfamiliar, because they involve lots of sort of parts here. All right, so the final question on the paper now is a question about projectile motions. So they're all the screen dumps from there. All right, so this one involves quite a few little parts as well. So we've got an object swinging at the end of a 0.5 meter length of string in a circular path with an angular velocity of, well, we don't know, completing each revolution in 0.24 seconds. So this is basically circular motion. And again, there's lots in this question. So if we're looking at circular motion here, we've got r, the radius of the circle, being 0.5. Omega is the radians per second, is the angular speed, which we don't know. But t equals the period, which is 0.24 of a second, which is 2 pi over omega. So let's solve that equation for omega. Omega is then 2 pi over 0.24. All right, so that's 26.18. And then v, the speed, is r omega, which is 0.5 times that, which is half, which is 13.09. Okay, so that's the speed of the object. The object is projected from a height of 0.3 meters above the ground in a vertical plane and just passes over a narrow pole as shown in the diagram below. So we've got this thing being projected at 0.3 meters above the ground, and it just passes over a point which is 14 meters horizontally and 2.05 meters above the ground. All right, so there's lots of things we want to find here. We've also got a little trolley there, which is 0.6 meters wide, and it's going to move away from that vertical wall there and narrow pole, and its height is 0.4 meters. And we want to find, in the next part of the question, what the acceleration of that trolley is going to be if the particle is then going to just pass over the pole and hit the trolley. Now, there's quite a few formulas that we need to know here. Some of these are on the formula sheet, some of them are not. So what do we want to find here? Well, first of all, this is a projectile motion, and we don't know the angle at which it's projected at. So if we don't know the angle at which it's projected at, I'm going to use the formula y equals h plus x tan alpha minus gx squared over 2v squared times 1 plus tan squared alpha. Now, the only thing that's unknown there is alpha. Y, what's y? Okay, so y is going to be 2.05. My initial height of projection is 0.3. When it hits or just passes through the top of this pole. Okay, so all the values there we've just worked out, or we can get. Y equals 2.05, H equals 0.3, X equals 14, V equals 13.09, which we calculated. So let's substitute all those values in and rearrange that as gx squared over 2v squared tan squared alpha minus x tan alpha plus h minus gx squared over 2v squared, or plus that. All right, now this is just a bit of arithmetic here. So let's get all those values, and I won't show the calculator just for basic arithmetic values, but we basically reduced it to this quadratic. Okay. We could solve that quadratic using the quadratic formula for tan, or we could, yeah, all right, so let's try that. Let's try and solve that quadratic for tan. Okay, so let's go to the calculator page. All right, so let's try and solve that quadratic formula. It was nsolve 5.604964. It was minus 14u. So that I'll say u is equal to tan alpha. So that's u squared minus 14u plus 7.35496. I want to solve that equal to 0 for u. Okay, now the calculator gives me one answer. We're going to be careful about that because that was the answer for u. Now I'll work in degrees for this one, so I'll change my calculator from radians to degrees. So settings, let's change the document settings on this document from radians to degrees. And let's go back to the current document. So the angle is tan of alpha, where alpha is 0.75. So what I want now is my trig. I want my inverse tan of that value. Don't need all the decimal places. All right, so the angle of projection for this projectile is now 36.9208 degrees. So when we solve that equation, we'll get 36.921 degrees as alpha. And I've shown there that it must be the positive root as using the quadratic formula, 14 plus or minus, but it must be the plus value of b squared minus 4 times a times c all over 2a there. All right, so that's part one of this question. There's a lot more bits to go. So as I said, we've got the flat top vehicle of length 0.6 meters and height 0.4 meters. That was initially at rest against the pole as shown in the diagram. At the instant that the object is projected, the vehicle moves in a horizontal distance away from the pole in the same vertical plane with an acceleration of a. The object then strikes the middle of the top of the vehicle. Using calculus, vector calculus here, and ignoring air resistance, find the value of a. All right, so what do we want to find now? Well, it's going to hit in the middle of the vehicle, isn't it? So we know now that the projectile is initially projected with initial height of 0.3. If it's going to land on the vehicle, then it's going to land when its height is 0.4, and that's going to be at some other position which is further away from the pole. So now we can use two other formula. So when the particle is at a height of 0.4 meters, which is 0.3 meters from above the point of projection, it lands on the vehicle. So now we know the value of alpha is 36.9, the value of v is 13.09. When y is equal to 0.1, I want to find the time when it lands on the vehicle. And the formula here is just y equals vt sine alpha minus 1/2 gt squared. So substituting y equals 0.1, v equals 13.09, and alpha equals 36.9. Okay, so I want to solve that equation for t. All right, so let's try and solve that equation for t. All right, so what am I doing this time? I'm doing an n-solve again. So menu, algebra, n-solve. What's the equation? It was 0.1 equals 13.09. That was my value of v, times the sine of alpha, just round it, times t, minus 4.9 times t squared, and I'm solving that equation for t. Now, I don't think that's right. Why not? Because if you think about it, there were two times that the particle was at a height of 0.01. Just when it originally got thrown up in the air, there's also another value later on. So two values here. The calculator only gives me one solution there, but this is a quadratic formula. There are two solutions. So let's try and find another solution, perhaps when t is greater than 1. Sure enough, that's the correct answer that we want. 1.59. So that gives me the time of 1.59. So I've found when it's at the height. What I want to do now is find, okay, what's the x value? Where is it going to hit that little trolley thing? So now I want to find the x value when t equals 1.592, v is 13.09, and alpha is 36.9. What's the formula this time? Well, x equals vt cos alpha. Okay, so, well, it's simple matter. X equals 13.09 times 1.592 times cos of 36.9, and that'll give me 16.6. So that's fairly easy just to calculate. What do I want? I want 13.09 times that value of t times the cos of that angle. Grab all these just from there. Okay, so that's 16.66, close enough. Okay, so finally now, what have we got? We've got this trolley, which was moving from rest. So constant acceleration formulae, s equals ut plus 1/2 at squared. The initial velocity was 0, u was 0. S is then 1/2 at squared. The time when it hits the trolley, t, was 1.59. We just discovered that. How far has the trolley moved in this time? Well, the trolley has moved 14.3. Why 14.3? It was originally 14 meters to the pole. It's hitting the trolley in the middle of the trolley, which is 0.3, and it's moved this extra distance of 1.267a. So finally, we want to solve that equation and get the final answer of a equal to 1.86. Okay, so that's fairly easy to do. So we can just do an n-solve. What's 16.666 equals 14.3 plus 0.5 times t squared. That's the value of t there, times a. We want to solve that for the acceleration. I've already used a, so I'll call it a1 again, and I'm solving that for a1. So that's my final answer there. The acceleration was 1.86. All right, so there's the solutions for paper 2 using a TI-Nspire CX calculator. All right, hope you've enjoyed that presentation for all our solutions there for Queensland QCAA paper 2 section 2. Thank you.